I never had my glasses clean like they're supposed to be. I don't know what the deal is here. But, alright. Alright, tonight I'm gonna do some more intelligent design theory as far as how the Earth was, the rock where the Earth was created. You've heard some of the geological, some of the stuff that the stellar evolutionists put out years ago because they didn't have access to a lot of information and stuff. And it's still in the textbooks, and unfortunately a lot of people look at it, even if it's in college textbooks or anything else, look at it as kind of biblical. You know, if it's in a book, that means it's necessarily true. But keep in mind that there's new stuff discovered every year. You know, every 6 months technology changes. So just because you got a hypothesis or a theory doesn't mean they were correct. So you constantly have to be questioning. To get to a certain goal, you have to create a strategy and stuff as to what are some of our hypotheses are. But one of the first things you have to do when you're creating a planet Earth is you have to build up the mass. We already know that. We know that even with Newton's laws of gravity, that the more mass you have, and the bigger the mass is, the more gravity you're going to have. So there's even been suggestions by several scientists and physicists that there's super Earths out there. You know, planets that are bigger than ours, and there's maybe a reason why they do that. Which is a possibility. But that becomes in an astrobiology question is how does that affect life on the Earth when you have a super Earth out there? When you increase the size of the planet Earth, how does that affect the biosphere? How does that affect all that out there? That has to be thought about, and you have to put your thinker together and listen to other thinkers and put out some new hypotheses and stuff as to how that comes into being. So, there's only two explanations, and I have proof of both those explanations, as to how you fuse rock together and when you're creating a planet. Now, the biggest problem we have out there in the universe is thermodynamics, the laws of thermodynamics. It's very cold out there, and you have to be able to warm objects such as asteroids, and you have to be able to fuse them together. You have to be able to produce heat. Well, it's not like a Native American out there sitting out there in the woods. He gets his flint together and he pops the two flints together and puts a spark, and he builds up enough sticks on it, it finally goes combustible. So it's not that. That's not the problem out there in the galaxy, in the universe. It's very cold out there. It's about 300 degrees below zero. And they know that there's something they utilize out there, especially when they're creating stars and planets, that brings temperature of the nebula 10 degrees above absolute zero. And they really don't have any explanation as to what can produce that kind of heat. And, you know, why it's 10 degrees just above absolute zero that you go outside the nebula and then it goes cold again. And they really can't, they don't have really an explanation as to what's doing that. But I think I got an answer as to the possibility on that. I'll get to that later. But we got two good examples of fusing rock together. One is lightning. I mean, there's photographs out there. I'll try to post them as to what we know that lightning goes to the ground up. It doesn't start out in a cloud. It looks like that because it happens so fast. It doesn't strike down. It actually goes up. People have been hit by lightning. They get this kind of it's kind of like static electricity. The hair starts to get real staticky and stuff, and they can feel the static energy build up, and the next thing, pop, they get knocked out. You know, it's because it starts from the ground. So, but we know that you can go about 6-7 inches into the ground where it's popped up and it's fused rock. I mean, it's not enough to put an asteroid together. When actually it would pop, it would break loose out, you know. Yeah, and we do know that lightning does go up there in the stratosphere, so it's not like it can't be used up there. We already have proof from NASA photos. I knew that it does occasionally go up there in the upper atmosphere where it's very cold. It's already, if you ever been up there in like Denver skiing and stuff, or even during the summertime, you go up to Mile High City, it's starting to get cool. You get up there to the mountaintops, it's really cool, and you go to the top of a mountaintop, and you got snow still up there, and it's July, you know. So it's very, the higher you go up there, the cooler it's going to get. But we do know lightning actually does go up there. We've got proof of it, and that's a fact now, is that we do know lightning does go up there. So it's not like lightning can operate out there, but you have to figure out how to generate it. So, and that's the trick for us to be able to fuse, ET able to fuse asteroids and rock together. ET has to be able to sustain that voltage. And we've never been able to do that. I've got a lightning book I've checked out. I've looked around in it. I've looked at some of the research notes, what's on the internet, and none of them had the ability to sustain the voltage. So we don't know what would happen if I can just keep it flashing. Bang, 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 make a lot of noise. And, but it's actually cool energy. It doesn't burn. If you ever seen a tree that's been struck by lightning, it just blows the bark off of it, and you get this nice tree, you know, just wet bark. It doesn't even burn it. It just blows the bark off. You know, there's people that survive lightning. So we know that it's not a burning energy. So it's fairly safe if you can actually control the energy. But that has to be demonstrated to be able to prove that I can fuse rock together. And with that, you have to be able to do that up near off the International Space Station. You have to be able to generate that kind of voltage out there, and they don't have the ability to generate that kind of voltage, especially the kind of intense energy that you need to overcome thermodynamics out there. Because we know that there's an energy out there that can actually raise the temperature of a nebula out there 10 degrees above absolute zero. So you're talking a lot of being able to overcome the intense coolness of the universe. It's a conditioned universe, and ETs want to create that universe as so that El Thermo, our sun, has a habitable zone. We can put a planet around it, we can live around it, and we don't get melted. Because that El Thermo produces a lot of energy. It's created by whoever created the universe, and whoever put the galaxies out there too. The other suggestion is how they actually put rock together. And we see it every day. You see it in volcanoes. You got proof that you've seen the after effects of volcanoes. The lava explodes up on the surface, and it eventually cools, and you get a nice island. You know, if you're terraforming another planet, you've already got your rock built up. You got to have some way of building up islands. Otherwise, the Earth's going to be perfectly round, and you're just going to have ocean water out there. Because it starts to rain, you have to be able to raise rock up. You got to be able to build that rock up to above sea level. So you have to figure out how volcanoes are created. Evolutionists said, well, it's the pressure of the Earth. If the Earth is molten, we've never been down there, so they have no proof that the Earth is actually molten down there. The theory is, well, because it's such extreme pressures down there, That's what gives the rocket's molten core down the center of the Earth. But they have no proof of it. We never have been down there. So that strikes that out. My suggestion is when they build a plant, they put something down there that can create that energy, and it can be utilized, and they can focus the energy on toward the surface and create that molten effect. Good case in point on that is that they're heading out to the sun, and they discovered something that violates the laws of thermodynamics. It's the outer atmosphere of the sun is actually hotter than the sun itself. So here's the sun's surface, and here's the atmosphere is going all the way out to here. The laws of thermodynamics say, well, the atmosphere should be colder because it's away from the sun now. It's entering the outer cold, and it should be cooling down. So you should get a cooler gas, but it doesn't. Now we have a problem because now the laws of thermodynamics have actually been broken. So when they created that sun, there must be something else going on that's creating that. Another case in point, when the sun goes supernova, the combustion, the fusion is over with. It's not, they say, well, it gets so down to be a white dwarf. That's what the stellar evolutionists have say. That may be right, that may not be right. But when the sun goes supernova, all that gas spews out into the empty space. So it quickly cools. It doesn't stay hot. I mean, it's 300 degrees below zero out there. That gas, I don't care what temperature it started out with, it's just like a volcano. When it comes to the surface, you've seen when it hits seawater, bang, there's a pop. And there's actually an explosion because of two extreme environments. You get hot and cold, and it actually increases the intensity of the explosion. So you get a real explosion, and then you get the volcanic lava just out there stewing, kind of spewing steam for a while, then it finally cools enough and you get a nice bed of rock. So, but here's the thing about the planetary nebulas. It's grown out there, and it's actually the gas is still bright. It's luminescent, and they really can't. It's a chemical reaction that creates that luminescence. It's not actually the fusion. It's also a chemical reaction which creates our sun. And we don't have anything on the planet I know that we don't know how to put a gas out there from the periodic table and make it luminescent out there in outer space. So there's something, part of the story is missing as to what the composition of our sun is. And because of that, it's a chemical reaction. The old stellar evolutionary theory says that suns eventually grow old and die. That may not be true. It's not really a fusion reaction, it's more of a chemical reaction. And normally they don't do that. They don't explode like that, which is a theory of mine. But you have to be able to, we do have fusion reactors now. They built one in France, so we know what the process is and what's going on in the reactor. So, but the sun's is a different story. There's missing stories. There's missing data. That's part of creating that star that we're still missing. There's a chemical reaction going on, and if it's a chemical reaction, it doesn't have to fuse. It's just creating energy. Then it's an endless source of energy. The stars never do collapse and grow old and then explode again. And that's the problem is that you have to be able to reconvert that back to hydrogen, and we don't have the ability to do that. But to take a exploded star and reconvert it back into hydrogen so that's something that we could use, you have to be able to convert gas. And we don't have the ability to do that, but that doesn't mean that ET doesn't have the ability to do that. But so we know it's a chemical reaction because when the star explodes, it's still lit up. So there's something else going on besides just that. So we have a fusion energy. We have an energy that's actually what's making the lava actually spew out there. And I would say it's something that's ET left out there at the center of the Earth that we'd have to discover. That's creating that volcanic lava, that flow out there. I think part of the answer they're going to discover when they go to the sun with this new NASA expedition and measure and study that outer atmosphere of our star, and try to figure out what's causing that, because it's a new type of energy that's part of the star that we don't understand. So we may get an answer as to what creates volcanoes by studying that energy. It's a very important probe, and we would be able to find that when we define a solution, that would be another. If we understand what's creating that energy, we can produce it through engineering. We could actually start fusing rock together, because we can go outside the space station, and engineering can actually produce something hot enough that it could actually fuse rock together, and you can actually take some asteroids and fuse them together, which would be great because you could actually mine asteroids. There's been a lot of suggestions on how to get the people out there in space, and you just take the asteroids, put them in Earth orbit, and we mine them. But you have to get your people up there and stuff, and you also have to be able to fuse those asteroids together. And we don't have a tool yet there that can do that. That if you understand what that outer atmosphere of the sun is, and we can produce that through engineering, then we got a tool that can actually fuse asteroids together. And if you got enough of them, you can actually create a planet. Or we could take them to Mars and crash them into Mars and start fusing the planet together and build up the mass of Mars and create another Earth-like world. So there's endless possibilities. So don't think we have the final story on what creates that. There's a world of opportunity there in science and engineering to figure out how to do that. So, but anyway, let's get back to this is everybody's seen the Star Wars movies. They've seen the Death Star and what it can do and stuff, but I would suggest that the Death Star is a possibility. Of all the Star Wars vehicles in there, the land speeder is probably correct. They'd probably eventually be able to create those. The X-Wing fighters, they could possibly create those eventually. But the Death Star might be a possibility too as to what creates that energy, enough energy that you could actually fuse rock together. And it's normally what it would be used for. It would be used to fuse asteroids together and get out there and have enough of a shield that it can take hits by asteroids and still fuse rock together. And keep that in mind, because that's what I think is circling Sirius. Sirius is one of our largest stars close. It's about 11 light years away. It's a blue giant. It's a very new star. Let's see, we got, it's about, the surface temperature is about 10,000 Kelvin, and the diameter is about 2.3 times the mass of our sun. And it has a yearly proper motion of 1.324 and PA in 204. So it's a very big star. And it's about 11 light years away, so it's fairly close. It's one of the largest. It's the brightest star in our visual astronomy, because it's so close, and it is a blue giant. So it's a new star. But what they discovered with the addition of new telescopes and stuff, and Sirius does have a white dwarf or something that's actually rotating around it. You can actually pick it up in the telescope. Pick it up in the telescope and pick it up and they can actually see it. It's very close to the Sirius. Their visual ability to measure distance out there, I question, but you know, it's so 11 light years is still a long way off, especially for a telescope. So maybe with bigger telescopes and stuff, we'll actually be able to measure the distance fairly accurate about how far it is from Sirius, because it is a huge star. And one of the things about Sirius is that it may have been a red star in ancient times. There was quite a lot of research done in that, because a lot of the philosophers and the astronomers in the 1500s and stuff were labeling it as a red giant, and it was actually appearing red. So that brings up a debate as to why now it's a blue star. It got converted. So I was telling you earlier that the possibility that ET has the ability to convert old gas or helium back into hydrogen, and they could actually create a blue star with. If that's true, then that would be an indicator that that's what they did. But what did that also may be what's orbiting it. They had the ability to convert, and that's one of the reasons why the Death Star is parked out there beside Sirius, is they're the ones that created the star. And they parked it out next door to it. The reason why it looks like a white dwarf from this distance is because it's got a plasma shield around it. What you saw in Star Wars, that's actually just a iron core. That's just, I don't know what they use for metal out there, maybe titanium, but it's just basically a metal core. And in Star Wars it says, well, it was shielded and stuff, and they had to bring the shields down. They had to shut it off from inside somewhere inside the center of it. But the outside of it, the outside of it is a plasma. It's probably very hot. They've done spectrometer readings from it, and I should have marked this, but anyways, it's hot. Yeah, it's 8,500 degrees or 9,000 Kelvin. So it's very hot. The shielding or whatever, since if that's the correct spectrometer reading, it's very hot outside the ship. But the shield is actually part of that energy. So you could actually create a Death Star with a shield. You could actually shield it. In the outer, it doesn't have to. I'll show you what my line of thinking is that the shield it stays on. There's no way to penetrate. There's no way to get into the side of the core and shut it down or whatever. They don't drop shields. If it opens fire, it doesn't drop shields, because the shield on the outside is also part of the energy. It's 85,000 to 9,000 Kelvin. It's already hot enough. It's already broken the laws of thermodynamics. It's warm enough outside there, and it's creating a nice warm, the energy is already out there. So what happens is when they utilize it, they just grow that plasma to whatever they need. If it's a bunch of asteroids that are fusing together, they just grow that plasma and they melt it and utilize it for whatever they want to. But the temperature is already over. It's already breaking the laws of thermodynamics. So we know it's a very warm energy that they can utilize. So but that's one of my theories. There's also a suggestion that there's a Sirius B, that there may be something else smaller out there that's not, that maybe the firing mechanism is right there where Sirius B is, and then they have another space station out there too, because the orbits of Sirius and Sirius B are kind of erratic. There's something else that's going on there. So there's a possibility that there's a space station out there, or a big space station or something, that's causing the orbits of those two phenomena, the star and Sirius B, to be a little bit erratic. There was Hubble, I can't quote myself on it, but I think they did find some planets. So there's been some work out there as far as building planets, but don't quote me on that. It's recent news, and I was looking for it before I went on the air, so don't quote me on it, but I do think that there are some planets they discovered around Sirius. So it's one of the candidates for, it's 11 light years away. It's a possibility that we could go out there and might find some life, and maybe the origins of us, Somewhere within 11 light years away is the origins of us being here on this planet. Somewhere 11 years, 5 light years, just based on stuff that's been put out, especially by some of the older religions and stuff, or Edgar Casey's Atlantis, that they did have some of the advanced science and stuff, but it sounds like to me that they only had the ability to go light speed. They were not Star Trek. They built a spacecraft that can go light speed. So if that's the case, they're somewhere within 5 to 11 light years away from us. But getting back to the proof that Sirius may have been a red giant a couple hundred years ago, is there were quite a few astronomers that depicted in their journals of being a red giant. This was put out by Robert Burnham back in the 1960s. So there's a lot of data that's come up recently, but most of them agreed that at that time that Sirius possibly could have been a red giant, which blows their stellar evolutionary theories, because red giants don't go back into being blue stars, brand new stars, unless they can convert energy. But that takes the ET factor out of it, that once they go into red giants, they explode and they become nebulous. And there's no way to reverse it. The only way to reverse it is ETs discover a way to convert gas, helium, back into hydrogen, to convert whatever gas had exploded and reconvert it into something they can use, which would make sense. That's good design. So, but there's different philosophers. I mean, I'll give you a there's about 5 different astronomers that claim that it was a red giant. So it does conflict with their stellar evolutionary theories at that time period, but most of them agree that it was about being red. So that to me would have raised a flag up that, hey, maybe we're not correct. ET has the ability to convert gas out there. So this is back in the 1960s, and there's quite a bit more data that's come up recently that would indicate that, especially when McKill Kaku gets on he's been going around visiting all the physicists and stuff around the world, and he come up with this, well, advanced civilizations are based on how they use energy. So, if that's true, then they know how to convert helium back into hydrogen, and we got a fresh star out there, which may be the story of Sirius. But, well, I've gone on as far as I was supposed to. That'll be it. And for this lecture.